Observation. We observe that the speed of the ball decreases on upward slope and increasing on the downward slope, and the direction of motion also changes continuously. From this activity, we learn that the speed and the direction of motion both change simultaneously. From the last three activities, Activity 3, Activity 4 and Activity 5, we conclude that the change in velocity takes place in three ways, such as speed changes with direction remaining constant, direction of motion changes with speed remaining constant, both direction and speed changes simultaneously. The motion of an object is said to be non-uniform when its velocity is changing, and the motion of the object is said to be in uniform when its velocity is constant. Now, let us learn about acceleration in detail. We learn that the velocity of an object can be changed by changing its speed or its direction of motion, or both. In either case, the body is said to be accelerated. Acceleration gives an idea how quickly velocity of a body is changes. We experience acceleration many times in our day-to-day activities. For example, let a train start from rest at station A. When it starts moving, its velocity increases, and after a certain time interval, it attains a constant velocity. As next station approaches, its velocity gradually decreases and finally becomes zero at station B. This rate of change of velocity of an object is called acceleration. Here, we can say that the term acceleration not only applies to increasing velocity but also to decreasing velocity. The decrease in speed as the body moves away from initial position is called deceleration. Deceleration can also be called the negative acceleration. As per the definition, the formula of acceleration of the body is shown on the screen. If the velocity of an object changes from the initial value u to the final value v in time t, then the acceleration a is v minus u by t. This kind of motion is known as accelerated motion. The acceleration is taken to be positive if it is in the direction of velocity and negative when it is opposite to the direction of velocity. Acceleration is also a vector and is directed along the direction of change in velocity. The SI unit of acceleration is meter per second square. If an object travels in a straight line and its velocity increases or decreases by equal amounts in equal intervals of time, then the acceleration of the object is said to be uniform. The motion of a freely falling body is an example of uniformly accelerated motion. On the other hand, an object can travel with non-uniform acceleration if its velocity changes at a non-uniform rate. For example, if a bus traveling along a straight road increases its speed by unequal amounts in equal intervals of time, then the bus is said to be moving with non-uniform acceleration. Now, let us derive the equations of uniform accelerated motion. Consider the motion of an object along a straight line with constant acceleration. Then, the acceleration of the object is shown on the screen. Let u be the velocity at the time t equal to 0 and v be the velocity at the time t and let s be the displacement covered by the body during time t. Therefore, the uniform acceleration is shown on the screen. Acceleration a is equal to v minus u by t. Then a into t is equal to v minus u. That is, u plus at is equal to v. Consider it as equation 1. Since the acceleration of the body is constant, hence the average velocity is equal to v plus u by 2. But we know average velocity is displacement by time taken. So we can write it as v plus u by 2 is equal to s by t. Consider it as equation 2. We get the following equations by solving the equations 1 and 2. Here, we get the equation ut plus half at square is equal to s. Consider it as equation number 3. By solving the equations 1 and 3, we get the following equations. Finally, we get the equation v square minus u square is equal to 2as. Consider it as equation number 4. The equations of uniform accelerated motion are shown on the screen. Note, if the speed of an object increases, the direction of velocity and acceleration are one and the same. If the speed of the object decreases, the direction of velocity and acceleration are in opposite directions. In such a case, at a certain instant, speed becomes 0. If there exists an acceleration of a body at a point where its speed becomes 0 for an instant, then the body returns in the direction of acceleration and moves continuously, like in the case of stone thrown vertically up into air. Now, let us study a few important points that ought to be remembered while using the equations of motion. The following points are to be remembered while using the equations of motion. Choose origin on a straight line. The quantities directed due right are taken as positive and due left are taken as negative. Expressing the displacement with proper sign is important. Displacement is positive while measured along the positive direction and is negative while measured along negative direction. Let us do a lab activity to find the acceleration and velocity of an object moving on an inclined track. Click each tab to know more. The aim of this activity is to find the acceleration and velocity of an object moving on an inclined track. The materials used in this lab activity are glass marbles, long plastic tube, digital stopwatch, books, steel plate. Take 2 books, place them on a table. Take a long plastic tube. Cut it in half along the length of the tube. Mark the readings in centimeter along the length of the tube. Now place one end of the tube on the books and the other end on the table to make an inclined track. Now take a steel plate. Place it at the bottom of the track. Take a marble having enough size to travel in the track freely. Now release the marble freely from a certain distance 20 centimeters and start the digital stopwatch simultaneously. Stop the digital stopwatch when sound is produced. Repeat the same experiment for same distance 2 to 3 times. Note the values of times in the observation table. Find the average time and 2s by t square for every trial. Draw the distance versus time graph for all values. In this activity, we observe that for every trial, the average time and the acceleration remains the same. With no change in the inclination, initial velocity and the distance traveled, there will be no change in the time taken for the travel and the acceleration during the travel.